I'm Charles Pooh. I will be talking about what's new in geometry. Thank you for being here. I'm going to talk about what's new in geometry. And it's what we have been doing since the last test conference. To start, essentially, the way I break the talk was essentially in two main parts. I'm going to talk about usability because our main goal, at least currently in geometry, since we released geometry, I think in version 10, is to kind of improve and make it more usable, make it easy to use, right? And there's two parts of that. One is the usability, improving and make it nice from visualization and other aspects, to actually add new function or what you expect to actually use as tools in the system. So I'm going to talk about usability first, and after that I'm going to talk about functionality, what we added. There's a kind of a mix between, but you are going to kind of see the distinction. And that will kind of give you also the idea of where we are going long term, because I kind of like that you get the idea of where we are going, and then you're actually going to see the big picture and how we plan to continue development. And the last part is also kind of the plan, the future, and all the different things we have been doing, as well as talking about the other talks by team member Jan and J-Bomb, if you want more details and more specific topic. Okay, usability first. Okay, so one thing you may have noticed in the system, for example, like in image, there is an attached cell, right? Or you look at other objects in the system where you're actually able to really like how they behave, image or graph, is because they run automatically, they have attached information to it and such, so you can manipulate them, without actually having to do the symbolic operation or programmatical, stuff. So what we're trying to do is also to kind of add that in the geometry. It requires some work, so we are kind of progressively, injecting that to our object. So I'm going to first talk about the attached cells. So here I will just take a basic example of the Beethoven. I should actually take a mesh region. Oh, fantastic. Right. So this is a mesh region object. And I will just resize it so we get enough space down there. So when you click on it, first the box is different than the normal graphic box, but you will see that you have an attached cell here. I believe we added it in 11.2 or such. So one advantage is, there is the usual behavior of a graphic. You can rotate it, manipulate it. So that's one thing. But in the attached cell, you kind of have it's kind of a contextual menu, an extended menu, specific for that type of object. So you can press on it, and directly you have a list of mesh theme. You can take it, look at the wireframe, for example, the list of line, or you can put a smooth shading on it. So the whole thing is done behind the scene. We apply it, so you don't really need to know the details or such, but you can also go to the documentation and see that. Right? Or you can take it and essentially add decoration around it, like in this case you add the bounding box. Or you can take it, change the orientation, top, bottom, front, back. Right? So that's kind of convenient. So there's that usability we try to add to the system. So you can just take your object, your geometric object, manipulate it, look at it visually, do all the kind of thing you want. So we hope to continue to actually add it to more objects in the system, at least in geometry, graphic object like that. And this actually works in 1D, 2D, and 3D. As usual, we cover all dimensions and stuff. So the 2D is also roughly the same, but slightly different. So you have a specific attached cell for the 2D and the set of options there. In the 3D, for example, the print part, you can actually directly connect to a 3D printer if the object is printable and such. And you also have an information box, which kind of provides you a summary information about the object. So it's kind of a delay evaluation where we compute it nicely. So that was one part in terms of usability, attached cells. So it's kind of there easily for you to manipulate. The other part is the auto visualization. Right? So one nice thing in general, like I said before, is that when you have an object, a graph, an image, you import an image, you see it. That's nice. A graph you evaluate, you generate a random graph, you see it, so you don't argue about it. You are happy. That's kind of one usability aspect, which is important. You don't even think about it. You don't return you a formal expression. Like in this case, a disk, you get a disk, right? That doesn't fit exactly with what we have like earlier, like a mesh, where usually you evaluate a mesh, you actually see it. So what we did in the, I think version 11.2 also, we introduced region, which is a wrapper around your primitive in this case. I should actually write it like this, more like a wrapper. So this is actually also an actual region object, but you visualize like a disk. So that allows you essentially to do any kind of operation on it. You can take that region and put it in area, and then you have it. Right. So for those objects like graphic primitive where we cannot change the behavior, it has been there for years, we introduce the wrapper regions for that. But one aspect of the wrapper region, which actually that's kind of the intersection with functionality, one aspect of the wrapper region is also that it per se represents the underlying set, right? So when you have a mesh region, right? A mesh region, in fact is a set of points plus a description, a partition of that region in space, right? But sometimes you don't actually want to look at that partition, you just want to manipulate the set of points. So one advantage of actually having region is that it actually kind of represent that underlying structure, part of the region. Just to kind of slightly show you that, so if you take this mesh, the linear mesh we generate from a set of random points, is a mesh region, for example, is true, and is a region in general. But you can evaluate region, you can use the wrapper region around it. You see first that you lost that, meshing structure. And if you even want to check, you can ask, is it actually a mesh region, Q? And it's not. It's false. So it's kind of the underlying stuff. You kind of, forget about the rest. So that's kind of the whole idea. Region provides you the auto-visualization, but it also kind of, represents a structure behind. And one of the crucial things also you have to remember is that, the way I see actually the geometry is that, we have the different constructors. And some of those constructors, like mesh, there's a whole subsystem around it, right? So you have, by subsystem, I mean a set of functions which actually work specially for that set, right? And you have other ones which are just, point set in general. And I'm making that, that main distinction because, I'm going to start to show actually some of the functions we introduce, and you see actually where that distinctions come into place. Where actually the behavior, the fact that you're a mesh, implies certain type of behavior, which in some sense is not really mathematically correct, but it's useful when you're in that subsystem. So I'm going to talk about, Boolean region and Boolean operations. So that's kind of a functionality we actually extended, this last release, I think 11.2. So first of all, we changed the behavior of region intersection, region difference, region symmetry difference. So before those operations were returning also a region intersection when they were working on symbolic expressions. So now all of them return you a Boolean region. So this is a basic example. When you do the region intersection of two disks, you get actually a Boolean region. The Boolean region is actually the representation. We look at the region intersection, region difference as the operation, right? And as we discussed earlier, some of the people, when they see this, they believe, they think that nothing actually happened. Right? If you have the object region around it, you visually get the result. Right? And this is kind of come back to what I just talked a little bit earlier, is about auto visualization. We hope that in the next future, we're actually going to do, we are going to make region intersection or that Boolean region auto visualize like that, automatically. Even though behind the scene is still that, that formal expression, that symbolic representation there. Right. So the hope is to make, introduce those functionality as well as, easy to use and such. But let's come back to actually those Boolean operations in general. So as I said, when you have a mesh region, what we decided to do is that when you operate them with, using a Boolean function, we kind of try to remain in that space of mesh. We try to preserve the mesh structure. We try to return you something valid. For example, if you take a region of intersection of two mesh, a mesh is a closed object, right? Closed is, intersection of two closed objects are closed, obviously, or the union. But if you take the difference of two closed objects, right, a disk and a disk, you make the difference, you remove it, you actually have an open boundary in part of it, right? But in the system currently, if you do, for example, region difference of two mesh, we are going to return you a mesh. So essentially, we close it, right, if you think topologically. Or like we say, we return the smallest boundary mesh, which contain that open object. So we kind of try to remain in that same subsystem. So a mesh region will return you a mesh region, a boundary mesh will return you a boundary mesh. So that's kind of a big change, and we are going to push it into most of the operation we have, right? Like transform region will also return you of a mesh region, return you a mesh region and such. So if you are used to work with mesh, you are going to, feel at home, and everything just works. Okay, so in that same direction, so I want to kind of show you some example here where we actually kind of try to preserve those behavior. So you take two expressions here, they are kind of exact, so two triangles. You compute the region intersection. So in the case where we can actually represent it with the object we have in the system, we actually return you that representation. So if you manipulate triangle, we hope to always return you a polygon or something close to it. We are probably not going to return you a mesh region. So we kind of try to remain in that same family or something more general. So you can take it and visualize it. So you have the two triangles, you intersect them, you get a polygon. And same thing for implicit region. So you evaluate two implicit region, you get an implicit region. And if you use the region wrapper, you actually get the object visually there. And if you take, two mesh region, you evaluate them, you actually get a mesh region. You don't get a formal expression, or you don't get a polygon there. Even though the two objects, you can think about it as two polygons, or two triangles, essentially. So we kind of try to keep in that same family, same structure. And if you manipulate, derived region, you get another Boolean operation, since it's a region intersections. And you can also visualize it, and you get the object there, 3D object. Okay. So I just want to shortly point out that essentially in this release, we actually added Boolean operation for 3D Boolean operation, essentially over mesh. So this is just the standard list of 1D, we can do Boolean operation. It's just two segments. In 2D, which we had before, we actually enhanced it, made it faster, more stable, and preserve that subsystem. We return you an operation over mesh, return you a mesh, polygon, return you polygons. And the 3D, here I have two boundary mesh. I can operate it and then get the boundary mesh. As I said before, this is the region difference, right? In terms of set theory, purely, this is not correct because you have a boundary you remove there. But since they are mesh, we return you an actual mesh. So it's something to keep in mind when you actually play with the system. Okay, so now I'm going to talk about the set of, other set of functionality we added. So one of the functionality, or one of the things we try always to do, is to give, to make bridge with other system, right, in the language. So one bridge is through image processing. So we have a fantastic image processing. So, and you can imagine, you take a mesh, it renders as a graphic, which is roughly like an image, a raster. So what have been done is that you can take a mesh and you can actually rasterize it. You get the actual raster using RegionImage. And you have the other way around. From an image, you can go and get a mesh. So I can take that output and I can do ImageMesh, and then you get a mesh region there. So you can go from an image in 2 or 3D to a mesh and the other way around. So that's kind of a nice bridge if you decide to go and do image processing, or from image processing you decide to use mesh algorithm. So one of the features was also added was region relations. So we added region equals, so you can actually check if two regions are equals. And so this also works for all the family of the region we have, from mesh to graphic primitives, or special region as we call them. So you can check, region disjoint, like in this example, you take a triangle and a disk, add a disjoint, we get true. Or you can check, is a region contained in the other region? So that's region within. So here I actually have a mix of an implicit region and analogous. You can use region within, and in this case it gave you, actually I should just, in this case it actually gives you the condition. So behind the scene we actually do also some symbolic computation for those set of families, as well as support of assumption and such. So that kind of work nicely. So, I mean, the list is long, but we kind of just, hopefully stop here and just tell you that, we have been essentially trying to improve the framework, make it faster, make it better, the usability, so it kind of just naturally work for you. You get what you expect, right? And in long term, we actually, plan to, add some new additional subsystem like polygon and polygon with holes, so polygon, polyhedron, polytopes. So that's something you may expect in the future. So we're actually intensely working on it, and we're also kind of continuously improving Boolean operations. So as you can imagine, in 2D, 3D, you kind of end up with a whole family of algorithm to implement, right? If you implement line-to-line intersection, and such. So we are continuously working on it and trying to improve it. So some of the objects currently you manipulate or you get a Boolean region. Maybe in the next release, you will start to actually return you another representation. Maybe you will auto-evaluate to a boundary mesh and such. So we'll continue to kind of improve that, behind the scene, as well as the general performance. So that's pretty much it. So I would like to invite you to go to the exhibit downstairs. We kind of have a geometry lab or booth where we show, the interaction between geometry and virtual reality. We have our 3D printing booth, and the whole team is downstairs to, for your question, if you have any. And before I close, I would like to kind of invite you to the remaining 2 talks. So yesterday we gave a talk on Unity Link, and at 1 p.m. you have, hands-on on Unity Link. So if you want to go and, really learn and play with Unity Link, stop by, bring your laptop. And tomorrow, Jan will be talking about geometric modeling. So that's an aspect I haven't really talked here, because you should go there. She will show you all the new constructor we have, as well as, how you can, play with Boolean operation we currently have, how you can actually build models on something concrete. And Jebom also will talk about, or we try to help you or give you an idea how to, solve your problem using the functionality we have in the system. So, thank you.